Alright, looks like a good time to get started here again. And right now we're going to continue talking about polynomial functions and graphs, and this time we're going to talk about our x-intercepts and our behavior at the intercepts. So we're going to start by talking about, well, how do we find an x-intercept? So let's say we've got a function, and we're going to have this function in a factored format. So I'm going to say we've got let's say we've got x minus 3, I'm going to have x plus 1 squared, and then I'll have x plus 5. So with this, I've got 3 different factors in this. Now, it's a little hard to tell, but we could actually tell what the overall degree of this function is just by adding up the degrees of these individual factors. So I'm going to think about that and I'll think about that, and if I take a look at, say, this first term, I've got a first degree term. The degree on this second term is 2 because of that exponent right there, and then the degree of this last one is 1. So I've got a degree of 1, a degree of 2, and a degree of 1. So overall, I could say that this is a 4th degree polynomial. And we know something about what those are going to look like. I know that those are going to look, those can look like, I'm going to end up with a couple different squiggles in here. It's going to end up with both the ends being up, and I could say that because I've got a leading coefficient of 1 when I do this. I don't have any other coefficients out here. So I'm going to have both ends up, and I could have at most 1, 2, 3 different turning points. Okay, so that's a couple things we can know about this, but let's figure out a little bit more. I know we have what we call a zero factor property. If I take a look at where our y is 0, so right here on our x-axis, I can figure out what values of x would make that happen. So from this first term, I could say, oh, well, if x minus 3 were equal to 0, then this entire expression would be equal to 0. So if x were equal to, say, 3, then that would be one of my x-intercepts. So this would be at that point of 3, 0. Okay. X plus 1 would also give us a 0. So I can subtract 1 from both sides and end up with x is equal to negative 1. So I've got another point here of negative 1 and 0. And then I've got this one over here of x plus 5 equals 0. So if I were to solve this for x plus 5 equals 0, I'd end up with x is equal to negative 5. So I have a third x-intercept. I've got a function here with 3 different x-intercepts. Okay. So this would be negative 5 and 0. Now, when we're doing this, I know I've got 2 ends up, and it looks like I'm going to have 3 different points where this is going to cross the axis. Well, I could have as many as 4 different places where it crosses the axis, or it might not even cross the axis at all. But what we're going to have with this, what we're going to have to figure out is what is the behavior at each of these intercepts. And this is going to be a little bit interesting. So if the degree of the term, or the degree of the 0, is odd, then what happens is the graph will cross the axis. If the degree of the term is even, then it is going to touch the axis. So, let's take this term, or this one right here. And we're going to go ahead and I'm going to just do a rough sketch with this. So, we had our x-intercepts were at 3, at -1, and at -5. 1, 2, 3, 4. 2, 3, 4, 5. And let's take a look at these. I know that here, because I don't have any coefficients in front of these, my everything is positive. So this is going to, my end behavior is up in both directions, because this is a 4th degree polynomial again. And now I have to look at what is the degree of each of these terms. Well, the degree here at this intercept is 1. So this is going to cross the axis at that point. The degree at this intercept is even. So it's going to touch the axis. It's going to look a little bit like a parabola at that point. And at this last 0, once again, it's an odd degree, so that's just going to cross the axis. So here we have it where I've got 3 different x-intercepts, and each of these, the degree at those points, or the degree at each of these intercepts, tells us the behavior of the graph around those. Now, we've got some other tools that we can use to figure this out, and let's go ahead and do that. I'm going to choose something a little bit different. Let's say I've got some function here where I've got like x minus 6, x minus 3, and I'll do x plus 4, and I'm going to have this one, actually I'll just leave it like that. So I've got 3 different zeros here. Now, from this, what I'm going to do is I'm going to make up a sign chart to figure out what the overall value of my function is, if it's positive or negative. So let's figure out, well, first of all, let's figure out our zeros. And I hope it's fairly clear that from x minus 6, I will have a 0 at 6. From x minus 3, I will have a 0 at 3. And from x plus 4, I will have a 0 at -4. So what I'm going to do is I'm going to make up a sign chart. And I'm just going to put in, and this is just a really rough number line. And I know the value of my function on this is going to be 0 at these 3 points. Well, let's figure out if everything altogether is going to be positive or negative. Well, let's see what each of my factors is. So here, we're going to make up a sign chart for all of these intervals for each of these factors. And this seems like a lot of work, but it's actually fairly straightforward, because I can look at what is the key value associated with this function, or with this particular factor. Well, with x minus 6, I can tell if my value of x is bigger than 6. Say I choose a value of 10. 10 minus 6 is 4. 4 is positive. So this is positive. I'm just going to put in a plus here. If it's less than 6, say I put in a 5, 5 is negative. If I put in something between negative 4 and 3, say I put in a 0, 0 minus 6 is negative. If I put in a negative 10, negative 10 minus 6, that's definitely negative. And for each of these factors, for each of these intervals, I can come up with what the sign of that factor is going to do. So for x minus 3, if I choose a value less than negative 4, it's going to be negative. If I choose it less than 3, it's still going to be negative. As soon as this factor becomes greater than 3, say a 5, 5 minus 3 would be positive. For this last one, x plus 4, well, if it were, say, negative 10, that's going to be negative. But if it were greater than negative 4, say a 5, say a 0. Oh, 0 plus 4, that's positive. And everything bigger than that's going to be positive. And because I've only got these 3 factors, I can see what the overall behavior of my function is going to be. So I can think of this as the combo of my overall function. So a negative times a negative times a negative would be a negative. A negative times a negative times a positive, negative times negative is positive, times positive is positive. Negative times positive is going to be negative. And a positive times a positive times a positive is a positive. So if I were to graph this function with this in mind, I would say, oh, and actually I'm going to go ahead and rewrite this up here so it's a little easier to see. So we got this negative, positive, negative, positive. If I were to graph this thing, and I have this 1, 2, 3, 4. So here's that 1, 0. 1, 2, 3. There's another. 4, 5, 6. There's another. I would say, well, this was negative over here. Becomes positive. Changes from positive to negative, so it crosses 0. Goes from negative to positive, like that. And sure enough, this looks a lot like a cubic function. This is a function of third degree. And that looks how we'd expect a third degree function. This looks like how we'd expect a third degree function to look. Now, notice I'm not putting a y scale in here. It's difficult at this point to put values to say what these turning points are. You'll get there in later math classes. But for now, I think that's what we've got for you. And if you have any questions, shoot me an email, and we'll catch you in the next video.